Hey there, guys and girls. So, I guess this is why I was asking you guys to keep checking your emails for. Um, yeah, this is something I've been wanting to try for a while, and because we're missing some classes this week, and rather than you just sitting there and going through the work I've left you, we can actually get me here in this little box thing teaching while I'm not actually there, and you can keep rewatching it, and I'm still going to go through the same information I'd do if I was there, but obviously in a smaller chunk, something you can keep watching over and over again. So the other day when I wasn't there, I left some work for you guys to start on chapter 7, which is what we're looking at here, which is loans, investments, and assets. So really what we're doing is taking all that stuff we looked at in chapter 6 and now bringing it together to what you would see in the real world and how your finances and how your loans are actually calculated. Our book drags this out quite a bit to start off with, so you will see that chapter 7.2, 3, and 4 are all talking about reduced balance loans, just looking at them in different forms. So let's have a look at our first slide here. So reducing balance loans part 1, spoiler, 3 parts, they're coming later. These are similar to what we looked at in the earlier chapter, that now we're looking at instances where you make an extra payment on a regular basis, which is classed as an annuity. So another key word, it's in bold, that we're going to keep in mind. This is kind of like if you look at your bank account, where you have a wage going in and then you may make some extra payments every week, or when you have some extra cash laying around. That's what we're talking about when we're talking about a repayment. In a loan situation, it's kind of like on your credit card, or if you have a credit card, it says every month you must pay back a certain amount. That's what this repayment is talking about in the loan example. A key thing we kind of really need to get our head around is this point here where it's talking about how time moves forward that the loan gets paid off quicker. So it's a little bit hard to get our head around, so let's draw a little graph. It's actually pretty tricky doing it just on a mouse, but we'll work through this. And this is going to be our loan in dollars. So let's say you take out, I don't know, a $10,000 loan. Pretty straightforward, not that big of a loan in the grand scheme of things. And what happens with a reduced balance loan? It starts off, let me change my color, let's use red because loans are bad, obviously. Not really. It starts off pretty straight. You don't actually pay much of it off as time goes on, you're just paying interest. It does get slowly smaller and smaller and smaller, but it's going to get to a point where all of a sudden it falls very, very drastically. And you, in this last part here, you pay that loan off super, super quickly. That's just a tricky thing to get your head around at the start, because you have to remember, if you're taking out this loan of $10,000, it's getting interest added on constantly. So if you're making a small repayment, but then your interest is bigger, look at it that way, you've now got this gap here where you're only paying off this amount, but you've got this much interest getting added on. So it could grow depending on how much interest you've got, but that's why we have this really slow part here. It takes a long time to start actually paying the loan off, and then it just drops really quickly. This is a common thing that VCAR like throwing on exams, just so keep that in mind when we're looking at visualizing what these loans look like, or any loan looks like really. That's why we've been looking in chapter 6, how to graph some of these situations. Down the bottom here we have the recurrence relation. So just like chapter 6, we're going to have a recurrence relation first, followed up by its actual rule, which will be on the next slide. What you have here, it's exactly the same as the reduced balancing loan we saw earlier in chapter 6, though we have this added on part down the bottom, which is negative D. So we're subtracting just our payments. So D just represents payments. How much are you actually paying off extra per week, per month, per day, or whatever the situation is asking of us. So let's have a look at the next slide, and we do have this really big formula. It is actually called the annuities formula. Can be called the reduced balance loan formula. It is all the same thing. Yes, it does look very nasty and big, and yeah, it is pretty big. It's not a lot of work out to do. Much like I've been asking you guys to do, these type of questions you do in one really big calculation rather than splitting up into smaller parts. This first part, so v of 0 multiplied by r to the power of n, is exactly what we've been looking at when we did the last part of chapter 6. So you see we have this huge addition here. So the takeaway d, and then we have our compounding or growth periods on the fraction. All this is doing is taking our payment and then comparing it to how much interest is growing. And this thing here, this little added on part, is what sorts out this graph over here. Why it starts off slowly and then drops down real quickly. A big R value is the same as what we've looked at in the past. Remember, when we chuck in our little r here, we have to also divide it by the compound period. That's what this r part here is mentioning. The worked example I left for you, and which we'll talk about later, kind of looks at how we can do all this, but like I've said, we're going to have to use a formula, get an appreciation for it, but then we're just going to use the CAS Financial Solver to help us, or not to help us, actually give us the answers. So let's have a look at this next part. And what your book kind of doesn't do, which is pretty stupid to be fair, is it doesn't really highlight what your repayment formula is. So that's just how we work out the D value itself, which is here, and what your total interest is, which is this formula here. So the total interest is going to be the amount of repayments you have made, subtracting that away from your principal. So we're just trying to find out how much interest was actually earned. What we also have is the CAS Financial Solver, which will do all of this for us. The only thing we have to keep in mind when we're dealing with all forms of reduced balance loans from here on out, if it will talk about a payment or a repayment, that just means now that for PMT, we're going to have a value. For all of Chapter 6, we left that at 0 because we weren't making any additional payments, but now we will. And that will be negative because if you're making a payment to a bank account for your loan, you're physically putting that money there, so you're losing it, so it will be a negative. You will notice on here, in this case, our V of 0 is positive. It's because we've taken out a loan, so we've actually got the money in our bank account or in our hands. So in this case, V of 0 is going to be positive when it's a loan, and when we calculate it, or if we need to calculate a future value, that will be a negative because that's how much you still owe on the loan. So that's how much you have left. And that really sums up this first part of reduced balance loans. We're just trying to bring everything we've looked at so far and wrap it up in a realistic sense, to be fair. And that comes to its own when we look at the worked examples that I left you guys and we printed off. So I'm just going to bring that up. Let's just get rid of this ribbon here. Alright, so it is this question. I probably should have super prepared so I didn't have to scroll up, but we're learning. So we have these two questions here, and I also gave you guys the solutions which are over here. So I'm just going to quickly talk to them and go through some key points about them. So we've got question 1. So a $10,000 loan was taken out over 2 years at a rate of 1.4%, debited monthly. And it's paid back with monthly installments of $640. Find the value of the first 3 payments. Like I mentioned on the lesson, if you weren't there, it should read find loan value after 3 payments. So that's what we're looking for there. So if I take all that information in this question, I have my V of 0, so my principal was $10,000. my R value, it is 1.4, but it's debited monthly, so we're going to divide that by 12. As for our D value, we now have that. It was given to that in question. That's $640. So we're just simply going to chuck all of that into our equation, which we have up here. So that's what I've done in this step. You will notice I don't calculate my R values individually. So you can see big R is this part here. I don't simplify that down at all. If we simplify that down and turn that into a decimal, we're going to run into a rounding issue. It will throw your answers off by a few cents, maybe even a few half cents, but you don't want those issues popping up and costing you possibly a half mark if it keeps compounding over time. So you're just going to put this huge calculation one step into your calculator. If you do that, you are going to pop out with 9,371 and 67 cents. The question does ask for 3, so you're going to have to do that calculation 2 more times, which is what we've got down here. And as per usual, at the end, you are definitely going to have to put that statement. So therefore, the 3 loan amounts will be, and state them there. You will notice that these loan amounts are going down over time. That makes sense because we've taken out a loan and we have to pay it back. So by the end, we should have an account of 0 after however long we need to pay this bank account off. Let me scroll down to number 2. Alright, we have a loan, in this case, of $24,000, and it's taken out for 10 years at 4% per annum, with the interest debited monthly, and has repayments of $420.50. So, part A, we're going to find the amount owing after 5 years. So you're going to have to pull all your information out. Always, always, always do what we've done here, and what we've been doing through all of chapter 6 really, is state all your variables. So we know V of 0 from the question, we know the D value from the question, we know our N value, but because it's debited or calculated monthly, we're going to multiply that by 12 and change that. Along with our R value, we know it's 4% per annum, but we're doing it monthly, so we're just going to divide by 12. And what I've done here is just put that together for big R, so we can see it all in one step. Now we have to use that really big formula we saw earlier, which I've rewritten down here. Looks scary. It takes you a long time to get used to writing it all, but that's what it should look like, and that is exactly what you should be putting into your CAS calculator. So just for the interest of time, I've kind of already put that into my CAS. So if I pull my CAS calculator up, this is what it will look like when you type it in. You need to have the brackets where the brackets are. You need to make sure you put your times in. So all this is exactly what I've got over here highlighted. So if I put all that in, and if I push enter, I'm just going to get exactly what I had down here. So the 60th value, or after 5 years, that's what my bank account loan is going to be. So $1,425.20. So it is a very, very in-depth formula. It does spit out a nice little number at the end, which is cool. What I've got up the top here on the notes is how we put that into our CAS calculator. We can chuck all of this into our financial solver and get exactly the same answer. What you do need to be wary of, that this is going to be a negative because it's PMT. You still have to change your N value. You just have to set your PPY and CPY to be 12. Remember, we never change our I value when we do the financial solver. And as I mentioned earlier, PV in this case is going to be positive because we've taken out a loan. If you do that and you leave future value empty and push enter, you will get a negative answer because you still owe that much money, but never, ever, ever, ever put that future value as negative $1,425.20 because it's not negative, it is positive. And that really wraps it up, guys. That's our first video done and dusted. Hopefully it works. Hopefully you like it. If not, let me know what you think and what we can do to change it. But I'm going to leave it there, and I'll see you guys on Thursday. Thank you.